In this video, we are going to talk about the Random Sample Consensus Algorithm, or RANSAC for short. Some examples of applications for the RANSAC algorithm are image stitching, where we want to combine two different images of the same scene seamlessly. Another is stereo vision, where we use images from two cameras to obtain depth information about the objects in the scene. Algorithm goes like this. First, we select a random subset of datasets that we have already obtained. The next thing we do is try to fit the new model to the subset. We then find the outliers and inliers based on some threshold and compare it against the currently best fitted model. If there is no current best model, or the new model has more inliers and is thus better, the current model is replaced by the new one. Step 1 to 3 is then repeated for a given number of iterations. So here we have a small example of using the RANSAC algorithm. We have some data points which forms a line with some noise, and we want to find the model which represents this line. We start off by randomly selecting 2 points, since that is a sufficient amount of data points to estimate the model. The model is then fitted to the points. The dotted lines on both sides of the line shows the threshold we use when comparing inliers and outliers. As you might already see, this model contains 4 inliers, but since it's the first iteration, the model is kept anyway. In the next iteration, we repeat the procedure. The algorithm selects 2 new random points, we fit the model to the points, here shown in the color blue, and check the inliers and outliers. When we compare it against the current best model, we see that the new estimated model only contains 2 inliers, which is worse than the previous 4. The new estimated model is then discarded. The same procedure is repeated for the third iteration. This time we get lucky and randomly select 2 points that gives us a model which contains 6 inliers, here shown in the color green. We then replace the current model with the new, as it is a better fit. We keep repeating this process until a model is good enough, or until a set number of iterations has passed. Now for the parameters. We can define P as the probability that over all the iterations we have selected a model which contains only inliers of a hypothetical best fit model at least once. U is defined as the probability of randomly selecting one of these inliers. S is the number of points we are selecting for each model. In the example, we have to select 2 points to form a line. N is defined as the number of iterations of the algorithm. The probability that we do not even find one good model, here 1 minus p, is the probability that we select at least one outlier of all n iterations. This gives us 1 minus p equals 1 minus u to the s to the n. Solving for n gives us this nice equation here. From this we can see that the number of iterations necessary only relies on the probability p, u, and the number of data points s. You might be thinking that if the dataset contains a lot of points and a large percentage of outliers, it might be difficult to find the best model by only choosing random data points. But fear not. As shown in the graph, the RANSAC algorithm works well even though the probability for selecting an inlier is low. Here we have an example of stitching 2 images together. We use the SURF algorithm to extract and match features in the 2 images and visualize them on top of each other. Each of the yellow lines are a match between features in one of the image and a feature in the other. These lines are the data points of our dataset. Most of the lines go in the same direction, but there are some lines that differ. Now we have used the RANSAC algorithm to find the best transition which most of the lines agree on, and discarded the outliers. By applying the model to the image, we obtain the result, which is a stitched image. Thank you for watching.